quiz number 3. Let's see here.
What's that saying?
1 second. Maybe I should call this A. I'll call this B. B. I'm gonna call this C. Is it more clear now? 38 degrees. Does anybody have a question about any of these? Is there any confusion about what I'm asking for? Got about 4 to 5 more minutes left. About 1 more minute. Wrap up your final ideas. The more work you show, the better. Okay, let's start to pass those guys up. Thank you. Thank you. Appreciate it. Thank you, sir. All right, now it's time for Travis Ruckmans. He's an undecided major. Long-term goal is to find a degree that helps me obtain a job that I'll love until I retire. Great goal. College is basically engineered to train you to go become employed somewhere. So depends on what you study. And you wondered when you were a little kid How many stars can the human eye see? Probably depends on the eye, right? Some people have good vision. Me, I don't have any vision. Basically, without glasses, I can't see. You guys are all blurry blobs to me right now. So I guess that's just kind of a dependent on each human question. But there is something called the Hubble Deep Field. Have you heard about that? The Hubble telescope is like this telescope in orbiting the Earth. It's like a satellite that's a telescope that orbits the Earth, and it can take really far distance photographs of our universe. And what they did was, you know how there's starry skies and whatnot? They said, you know what, I don't want to look at like some region with light. Let's look at a really dark patch. A patch that seems like there's nothing there. So they focused the camera there and took many long-term exposure snapshots. And from the darkest region of the universe, they found that it was just like filled with swarms of almost uncountable amounts of galaxies. So even in the darkest parts of the sky, if you zoom in, it's filled with like millions, billions, trillions of galaxies. It's incredible. So I'll hand this back to you now. You all got 100 on it, so everybody got 100 on this quiz. I've uploaded solutions to quiz 1 and quiz 2. I will definitely upload solutions to quiz 3, but do you guys want me to go over it real quick, or should I move on with lecture? It's up to you. Oh, since nobody cares, really? I'll be uploading solutions to it, so you can get it there if you're wondering about any of the steps. Number 3 really alludes to a concept that I really want to talk about today. It's called the unit circle. And I don't know why your book doesn't start off talking about this. If I were to write this textbook, a textbook on trigonometry, I would definitely start off with the unit circle when I think about trigonometry. It is a fundamental concept in mathematics. So actually, trigonometry is not the study of triangles. Trigonometry really is the study of the circle, where our tool is the triangle. Our tool to study the circle is a triangle. So what do we mean by that? What do microbiologists study? Cells, microbes, viruses, bacteria. What do they use to study these guys? Microscopes, right? They historically first used microscopes, and then more advanced biochemical tests got created. A very well-known biochemical test that keeps being talked about in today's society due to the pandemic is PCR. It stands for polymerase chain reaction. Any pre-meds in here will learn about that soon, either in your first biology classes or definitely in genetics. What you do is you get a strand of DNA, you put DNA polymerase in there, and you put a master mix in there, which causes the enzyme to get activated. And what it does is this technique will create millions, trillions, quadrillions of copies of one single strand of DNA. And then you run it through a gel, an agarose gel, and you run an electrical current through it, and it will separate the DNA strands for you. It's very cool, very cool. Okay. But really, notice that if I have a circle here, and I'm at some arbitrary angle theta from the x-axis right here, notice that when I intercept the arc of the circle, wherever I do so, I can create a straight vertical line down like that. I could pick another angle, let's say from here, and I could create a straight vertical line like that. And no matter where I pick it, each time what gets created? A what triangle?
Right triangle.
Yes. You can create a right triangle every single time. So this is what I mean by trigonometry is not really the study of triangles. It's using triangles just like microbiologists use the microscope and how astronomers use telescopes. Our tools to studying the circle is the triangle. And here's what I mean by that. Again, here's my X and here's my Y. Let's say I'm at some arbitrary angle theta. I create my right triangle here. Let's call this value and to avoid confusion, I'll make this capital X and capital Y. Let's call this distance Y, X, little x, and call this distance Y, right? So right here, I'm at Y, and right here, I'm at X. What is the cosine of theta? If this is a unit circle, its hypotenuse is the same as the radius of the circle. And a unit circle means a circle of radius 1. So the radius of the circle is 1. And so that radius of the circle is the hypotenuse of this triangle. And the radius of the circle will always be the hypotenuse of any triangle that we can create using this system. So what is the cosine of theta?
X over 1.
Excellent. Adjacent over hypotenuse. I'm so glad you didn't just say X. Good job. X over 1, which is just X. But man, this intermediate step is so important because it occurred in your brain. And when you just say this step, this intermediate step gets lost. And it's so important that if anything, that intermediate step is the most important step. Between this equation over here, these two that connect get all the hype and all the value in society. But really, without that bridge, without the logical bridge, we would have never discovered that truth. So the intermediate steps are of the utmost importance. So look, cosine just equals the x value of any triangle we create on the unit circle. What about sine? Sine of theta equals what?
Y over 1.
Excellent. Opposite over hypotenuse. So take a look. Sine has the value of the y component for any of the triangles that we create. Any of the triangles we create. Right here, the y is greater, the x is shorter. Right here, it's about a tie. Right here, the x is actually longer than the y, and here it's about a tie. Okay, so at any arbitrary point on this circle x, y, we've deduced that this can be parameterized as, I'll put the equality up here, a cosine of theta and a sine of theta. Would you disagree? If I write xy is equal to cosine theta, sine theta, would you guys throw tomatoes at me and disagree and mutiny? Or would you think that's pretty logical? We just solved for it. X is equal to cosine of theta, y is equal to sine theta by definition, right? Just by definition. So this is what you mean by trigonometry is really the study of the circle, because we utilize the cosine and the sine function to parameterize changes in the projections of the x and y coordinate of a circle, respectively, with changing angles emanating out of the origin. That is what the study of trigonometry really is. Now, in our study of trigonometry, we like to talk about special angles where the sine and cosine values are well determined. Okay? Those special angles are at 30 degrees, 45 degrees, 60 degrees, 90 degrees. How do I come up with the rest here? I don't know. I don't memorize it, so I don't know what the next numbers are. But I notice a pattern. 30, 45, 60, 90. Let's list it. It goes from 0 to 30 to 45 to 60 to 90. So it seems as if the pattern is add a 30, 15, 15, 30, and repeat. 30, 15, 15, 30. If you follow this pattern, you will generate all of the special angles. So if I'm at 90 here, it repeats 30. So 30 plus 90 is what? That's right, 120. 120 plus 15 is what? 135. What's 135 plus another 15?
150.
150? $30, 15, 15, and 30 plus 150.
180.
And the pattern repeats. 30, 15, 15, 30. So what's 30 plus 180?
210.
210. What's 15 plus 210?
225.
What's 15 plus 225?
240.
Very good. So it's 30, 15, 15. The last one I got to add a 30, right?
270.
So right here it becomes 270. So I'll write the 180 out here. And I'll write the 270 down here. So then the pattern repeats. 30, 15, 15, 30. I add another 30 to this to get what?
300.
300. Add a 15 to that, I get.
315.
Add a 15 to that, I get.
30.
Add a 30 to that, I get.
360.
I'm sure you guys have all seen the unit circle, right? Who here has seen the unit circle before? Okay, everybody. Who here was told to memorize it? You don't have to memorize it, dude. Just know, start at the angle 0, 30, 15, 15, 30. That's the pattern. Start at 0, add 30. 0 plus 30 is 30. Then add 15 to 30, you get 45. Add 15 to 45, you get 60. Add 30 to 60, you get 90. And repeat. That's just the pattern. That's all mathematics is. It's recognizing patterns. So we don't have to memorize these special angles ever again. Ever. Just remember 30, 15, 15, 30. You can generate this from scratch very easily, very quickly. Now, back to this discussion about cosine and sine parametrizing the x and the y. We want to talk about what is the cosine and sine here. 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 Whenever you say the same word over and over again, it starts sounding weird, huh? I always think that. If the cosine function parametrizes how much x there is in a triangle, what is the cosine of 0?
It'll just be 1, 0.
Yes, 1 is the value for cosine. 0 is the value for sine. Notice that I could create a triangle here, It's a very small triangle. It has one leg 0, the other leg 1, and the other leg is a hypotenuse, which is 1, but that leg is really the hypotenuse. Really, it's the triangle that got squished. Notice if I get closer, 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 the y value becomes smaller and smaller and smaller to where there's no more y value. There's only x. And that x value is the value of the radius of the circle. Now let's move on to 30 degrees. What is the x value here and what is the y value here? Your book just tells you to, it basically presents it in that fashion where, you know, you got the 30, 60, 90 triangle. And it talked about what is the ratios. One is like square root of 3x. The other one is x. The other one is, the hypotenuse ends up becoming what? 2 times the other leg. So here, when we're at 30 degrees, we can also generate a 30, 60, 90 triangle. And because of that fact, what is the x parameterization value? Yes. Based off of that triangle, it's root 3 over 2. And what would be the y parameterization?
1/2.
Yes. So when I say x on the unit circle, you think cosine. And when I say y on the unit circle, you think sine. Okay. Now, what is it here at 45 degrees? Well, you have a triangle that's a 45, 45 right triangle. And actually, this leg and that leg are the same length, right? And the hypotenuse is 1. So if they're the same length, what must the sine and cosine be? Equivalent, right? So what is those values? What are those values? What is those values?
Root 2 over 2.
Yes, they're both root 2 over 2. That is what these values are. Then when we move on to 60 degrees, really your reference point changes. And so these values swap. And then at 90 degrees, how much x do we have?
0.
You have no x, which is how I like it. How much y do you have? Moving on, you guys notice how this goes from 1, root 3 over 2, root 2 over 2, 1/2 is 0. And notice how this is a true statement. Numerically, if you plug it into your calculator, this is true. That is another pattern that repeats. When you start off at 1, the x just moves on to the next value. And then over here on this side, because it's on the left of the origin, you have to put a what on the repeated value here? Very good. So this becomes negative what? Yes, negative 1/2. Because like the pattern here, it went like this. And now it goes in reverse with a negative on it. And so the next x will be what? With a negative on it. The same thing is over here, but with a negative on it. What was the y here? Same thing as over there, but still positive because it is above the horizontal. And anything above the horizontal is positive for y, and anything below the horizontal is negative for y. Anything to the left of the vertical is negative, and anything to the right of the vertical is positive. So what should be the y parameter here? Y value.
Root 2 over 2.
Yes, and it's positive because we're above the what? X-axis or the horizontal. Very good. What about here? To find out what this is, look over here. The y is the same, but what is the x going to have in front of it?
Negative.
Very good. And over here, how much y do I have? No y. How much x do I have? Just how I like it. Now what about right here? Notice that the pattern repeats. We got here to its negative version for x. The pattern will repeat because we achieved the highest negative value, and it's going to go back in reverse. You guys see that? Negative root 3 over 2. Furthermore, the y started out here, and it's going to go in reverse as well. And it will have a negative value because it is below the x-axis. Do you guys see where this is coming from now? There's no need to memorize this stuff. There's just one or two simple patterns in this stuff that if you understand that, there's no need for memorization whatsoever. Shame on your teachers for telling you to memorize that stuff. Absolute shame on them, because they could have realized these patterns and told them to. That way you wouldn't think math is about memorization. You'd think that accurately that math is about understanding. I say that because I'm a little salty. I too was a student who was told memorize this, memorize that. And I didn't like that. I didn't like it when there was no justification for what they were teaching us, or any type of reason for it. It was just memorize this contrived weird circle with these weird values. I don't even know why I'm doing it. And I don't even know where these values come from. I'm just told to do it. I don't like that. I'm sure you guys don't like that either. No one likes being told what to do just for the sake of do it because I said so. Who here likes doing stuff because someone says so? See, nobody likes that. I can't think of a person who likes to perform a command just because I said so, just because someone said so. In this class, you will never be told to do something just because I said so. I guess maybe turning in the quiz because I said so. You got to turn it in and get credit. That's just a minor example. What is this value here? As the pattern goes this way for x. Oh, I mean this way. It's right here. It's going to go that way because the x is shortening. You guys see over here, the x has no value. I'll give you a hint that the x is nothing here and the y is negative there. X is approaching having 0 value. So over here, it's got to get smaller, right? So it's got to go to the next value in the pattern. And what would the y be? The y is going in the opposite direction. It's increasing in value, but in the negative. Is it clicking? Is something clicking that hadn't clicked before? Raise your hand if that's true. So you guys already comprehended this pattern? Well, that's good. I'm just solidifying it now. So now over here, this value becomes still negative, becomes 1/2, and this value becomes, oh, it's actually the x is now positive because we're going to the right of the origin. Since we're below the horizontal, this is still negative. And this is then beginning to increase in value, still negative. And this is beginning to increase in value, still negative, and we've completed the unit circle. I expect you to be able to do this. I expect you to be able to start out with an empty piece of paper and to be able to come up with the whole unit circle and all of the associated sine and cosine values at the special angles. That might come up on the test. I don't know. Okay. I just got tired of the book dancing and prancing around this concept. I would like the book to be a little bit more explicit about the unit circle. So now let's talk about, what section is this, 2.4? Reference angles. So let's say I have some angle like this. Here's some theta. The reference angle is the angle that is formed by the terminal leg and the x-axis. So when I draw that angle like that, theta is not our reference angle. Our reference angle is this one. So here's an example. Let's say I come over here and I'm at 101 degrees. What would be our reference angle? It's this angle here, right? It's this angle theta. So what would be our reference angle?
79 degrees.
How did you come up with that number?
180 minus 101.
Okay, so the reason you get 180 and subtracted by this value is if this whole thing is 180 and this thing is 101, then this piece must be the difference between 180 and 101.
Yes.
So that is our reference angle, 79. What if I go like this? I'm at negative 103 degrees. What is the reference angle there? It's defined as the angle the terminal leg makes with the x-axis. So it's this angle right here.
77 degrees.
How did you come up with that number?
180 minus 103 is 77, but since it's negative, it has to be negative 77 because it's on the like the opposite side of the x-axis. Right.
Yeah, I mean that's a good way of thinking about it. I forgot to mention one last piece of the definition here is that your reference angle theta needs to lie between 90 degrees and 0 degrees. And here's why. I deleted the unit circle here, but the reason why we want our reference angle to be between 0 and 90 degrees is so that we can just understand what the sine and cosine values are in the first quadrant. Because once you know what the sine and cosine values are at the special angles in the first quadrant, then you can associate, you can figure them out for any of the quadrants. You just put a negative on it when appropriate. So that's why this needs to be true. So I didn't give you all the tools necessary to do it yet. So now, with that information, what is the reference angle? So first it would help to make this angle a positive value, right? How can I do that?
Rotated
Rotate it by how much?
360 degrees.
Yeah, we'll take this negative 103, add a 360 degrees, because that will just land it in the same spot. Yeah, matter of fact, this is negative angle rotation. Adding a 360 would pick this up and rotate it like this and put it back in the same spot. Clockwise rotation is negative. Counterclockwise rotation is positive. So what's 360 plus 103? Negative 103.
257.
257, I'll believe you. I can't do this in my head. That sounds like a feasible answer because it's in the third quadrant. So now we figured out that this angle is 257. That's still not the reference angle though, right? The reference angle is this angle right here. So if the hole is 257 and we wish to know what this piece is, what do we got to do? We subtract from this a quantity that will land it in an analogous position in the first quadrant. If I subtract 90 degrees from this, this lands right here. Subtract another 90 degrees from it, it lands right there. So 90 minus 90 is negative what?
180.
Yeah, so I subtract from this what?
180.
Negative 180. I mean, you should just subtract 180. If you subtract negative 180, you're adding 180. To be overly technical. So what does that equal?
77 degrees.
77 degrees. You guys see what I'm saying? Very good. Very good. So that's the concept of a coterminal angle. I should have let you know where the angles range through. Okay. So let's now find the trig functions at any angle by first turning it into a reference angle. And I'll have you guys know this is the last section in the book.
So got hacked. That's my new one. I swear yesterday, all of a sudden my stuff just got hacked. It was insane. Very like this, but it said like,
My apologies. I had to micturate and cool off a little bit.
you okay?
Yeah, I just feel like really like hot.
So you had to spread water.
Yes, to cool myself off. Maybe it's because this is a long sleeve. I don't know. I don't know. Professor Niazi problems. Yes, I'm fine. I just had to go micturate. Who here knows what it means to micturate? It's an overly technical medical terminology here. You guys are all right now urinating. Because urination is just the process of creating urine. So we're all filtering uric acid out of our bloodstream right now and all those various chemical byproducts that need to be ejected out of the body. So we're all urinating right now, unless you have a kidney failure. But micturition is the process of ejecting it out of your body. So now, go impress your friends by saying the word micturate, or I need to micturate. And tell them that you guys are all urinating on yourselves right now. Everybody is urinating right now, unless you have kidney failure. This is what happens when you have a socially awkward math nerd in front of you that is also a nerd in other aspects. I have a bachelor's degrees in biochemistry, math, and physics. And I believe you're a biochemistry major, right? Yeah. I first started biochem at SNU, and then I slowly started to move towards math and physics. But yeah, I still love that stuff. I still love biochemistry and stuff like that.
When did you sleep?
Never. I didn't sleep.
That's the problem.
That's very bad.
Yeah.
That's why I have all this brain damage and I act weird.
And you sweat a lot.
And I get hot a lot. Yeah. You know, don't be like me, guys. Don't end up like me. Make sure you get enough sleep. Okay? Rome was not built in a day.
What do you do to keep yourself energized? Do you like drink anything or eat anything?
I drink water, drink coffee, and exercise very regularly.
Ever had a bang?
A what?
A bang?
Oh, you mean those drinks?
Yes.
Oh, no, I'm good on that. It has creatine phosphate in it, and your body naturally produces creatine. Creatine is a naturally occurring molecule in the body. What creatine does is when your body metabolizes adenosine triphosphate, ADP gets converted, adenosine triphosphate, ATP gets converted into ADP, adenosine diphosphate. But what creatine does, creatine, PO4, creatine phosphate, it phosphorylates to ADP and converts it to ATP. So you can have more like strength to do stuff. That's why people take pre-workouts that have creatine in it and stuff like that. It's to do this process and give you more energy while you exercise. But your body naturally has creatine. And to give yourself excessive amounts of creatine is not very healthy. Not very healthy. It's actually very hard on the liver and the kidneys to metabolize all that excessive creatine. So, yeah, that's my spiel on pre-workouts and bang or whatnot. What you call that stuff?
And you've never had it?
I never had that, but when I was a young student of that game, I did take pre-workouts, and I regret it because it's not that good for your health. So.
You ever had Red Bull?
Yes, I had a lot of those.
Yeah.
Studying late night, yeah, late night studyings, yeah. I had 5 or 6. Yeah, not good for you either. I go for like something with no sugar, just like coffee, no sugar. The sugar is very terrible for you, even though it gets you very turned up, as you young kids say these days. It does work. It does the job. Okay. So now that that cool stuff is talked about, let's say, what is the sine of 135? Or no, that's not here, 225. Let's say I rotate 225 degrees and I'm right here. Okay, what is my reference angle theta? Because I really want to know what sine of 225 is. But even though you can memorize it and derive it, it's just nice to just base off of it as the first quadrant in the unit circle. So what is the reference angle of 225 and how did you come up with it? So remember, a reference angle is an angle theta that lies between 90 degrees and 0 degrees, and it's the angle that it makes with the x-axis. So it can't be 125.
It's 45.
Oh, how are you coming up with that?
I mean, it's not really hard. It's just.
Tell me how, though.
Well, 225 is correlated with 45 degrees.
Oh.
Because they have the same like cosine and sine, but they're both on the third quadrant it's negative. But yeah.
That's a very broad out answer. I want a rigorous answer. It's okay to have a broad out answer first, but then you have to make it rigorous. You guys know what bro science is? You guys don't know what bro science is?
Can you explain that?
Bro science is like stuff dudes tell you that works, but they don't provide justification on like why.
Bro science?
Yeah, it's just,
When was that invented?
I don't know, man. I'm just making stuff up.
Wait, so.
I'm trying to keep you
told us it
guys.
was a lie.
Pardon me?
You told us it was a lie then?
No, it's not a lie.
Well, then why did you say that it's not true?
Well, I didn't say it's not true. I said provide justification for it. You guys are getting real familiar with me now. That's good. You guys are laughing and having fun. That's what I want this class to be. I want it to be fun. We all have to be here, don't we? We all have to take this class and understand it and pass it, right? Why not have fun with it, man? Why not have a good time? That's my philosophy, okay? So how do you come up with this reference angle? Tell me what you did.
Well, since it's 225 degrees,
What do
that's
I-
the third quadrant,
Mhm.
right? And it has to be within 0 and 90 degrees, right? So 225 is at that mark where it's 45 degrees, and it has like negative.
This is what you're saying.
2. Yes.
Right across it, it's 45 degrees.
Yes.
Here's another way of thinking about it. Every time I subtract a 90 degrees, it lands in another quadrant
Yes.
next to it, and then I subtract by another 90 degrees, it'll land in our desired first quadrant. So what is that value you subtract from it?
180.
Yeah, minus 90, minus 90. And so this equals what?
45.
Aha. So sine of 225 is the same thing as negative sine of 45. Why did I say that? Because it has dipped below the horizontal. It has dipped below the x-axis. So sine of 45 normally would have been root 2 over 2. But for us to honor the fact that this is really in the third quadrant and sine and cosine have negative values here, we got to put a negative on it, right? That's how I want you guys to think about this stuff. That's what I'm trying to hammer home, if you will. Let's do another one. Let's say I rotate and I'm over here at negative. Let's rotate even more. Let's rotate and be here at angle negative 330. What is the reference angle? That's the angle this makes with the positive x-axis.
– 60 degrees.
How are you coming up with that number? You breathing hard, but that's what the test will expect you to do.
360 minus 330 degrees equals 60 degrees, which is a reference angle right here.
Aha, there you go. On your exam, you will be asked to show your work. On your homework, you'll be asked to show your work. On class, I'm going to ask you to show your reasoning or explain your reasoning. So yeah, I know this is a negative angle. Our reference angle has to be a positive angle between 0 and 90. Why not just add 360 to it? It does everything we want. It gets it in the first quadrant, and it makes it positive. And it makes it in this theta range. So yeah, that's a positive 30. So this angle theta is positive 30. So what is the sine of negative 330 degrees? It's the same thing as the sine of positive 30 degrees, which is what? 1/2. How'd you come up with that? No, it's okay. That one I won't ask. You would have to derive the whole unit circle. Yeah. You know, us mathematicians, we find it enjoyable to explain how do we come up with stuff. Justification is everything to us. We live and breathe and die justification. Some of those mathematicians will actually die because they'll fight each other at math conferences. Can you imagine?
Is that what you do?
No, I have never gone to a math conference because I'm scared.
Why are you scared, man?
because I think they might hurt me.
Why would they hurt you?
Because I may say something too revolutionary.
Isn't that better though?
It is better.
Yeah.
I have to make sure I think it through before I go. I can't die by attack of 100 nerds for no reason. I must not die in vain, is what I'm trying to tell you. This guy.
Just don't die, dude.
Don't die,
Just don't die. Just bring a pocket knife.
No. None of that.
Why not?
No.
Try to defend yourself.
No.
You're not trying to die, right?
None of that. Nope. If anything, I will have to use a book or something. I'll just chug books. None of that. I don't want to do
So
that.
you're pacifist.
Yes, I'll just run away. I'll just out sprint them. Okay.
Disrespectful.
Yep. Okay. Let's do another example because I really think you guys are getting this, and that's making me very happy. What about we rotate and we're at negative? I shouldn't have rotated that much. Now I have to think. So this was one full rotation, that's negative 360. And then this is almost another near full rotation, so I probably another minus 180. And instead of minus 180, let's make a problem that's non-trivial. So let's say that this angle is like 460, negative 460. What is the cosine of negative 460? So to do this, we have to create reference angles. What we want to know is what is this angle right here, theta. Again, negative 460 is the same thing as adding a 360 to it. So notice that becomes just a negative 100. We're still negative. We're still not where we want to be. But guess what? Let me just add another 360 again. You can add another 360 until your heart's content. And so this becomes 260, positive 260. So that's still not theta. We figured out what is this angle. So yeah, the way I've drawn it, it probably needs to be like right here. The way I've drawn it means that I didn't draw it right. It means it needs to be around like right here. There we go. Like that. Because, 270 is right here. It's falling short of 270. So our reference angle is this angle that we aspire to find. The angle it makes with the x-axis. How do we find that? How many quadrants away is that first quadrant? 1, 2. So I subtract how many 90s from 260?
180, so 2.
Yeah, I subtract 2 90s.
That's 80.
Yeah, it's 180.
The same as 80, isn't it?
Yeah, it's 80. So our reference angle is 80 degrees. So the cosine of negative 460 degrees is the same thing as the cosine of just 80 degrees. And that's not a special angle, so we don't have to evaluate it. Your calculator can evaluate it. And we'll develop some mathematics that will allow us to analytically evaluate it, but not yet. Yeah, that's right. Okay. Now, we need to come up with an example where it lands in the fourth quadrant. So how about I'm here at positive 315. Oh, wait. Yeah, 315. What is our reference angle theta? And also, what is, let's say, the tangent of 315?
Reference angle is 45 degrees.
How'd you come up with that?
Because 360 minus 15 is 45 degrees.
360 minus 15?
315.
Okay. So let's see.
260 minus 15 that equals 45. So.
Okay, so what we've done is we say this total amount is 360. This orange amount is 315. The difference between 360 and 315 is this angle between the x-axis. So that's why it has to equal 45 degrees. So this is equal to the tangent, wait, let's put a space here. The tangent of 45 degrees. But what do I put out in front of this tangent here and why? Because it's not just equal to the tangent of 45 degrees. It's a little more complicated.
It's 1, isn't it? Or it's, wait, no, it's negative 1. Right.
Tell me what is the sine and cosine value in the fourth quadrant?
Root 2 over 2, negative root 2 over 2.
No, I mean positive or negative. Is cosine positive in the fourth quadrant? Cosine is positive. Is sine positive in the fourth quadrant? No, sine is negative, right? Recall tangent of an arbitrary angle theta is a ratio between sine of theta over cosine of theta. So if sine is negative, then the tangent of 315 is the same as the what tangent of 45? Because this sine is negative in the fourth quadrant, we have to respect that. So we got to put a negative here. Because really we're evaluating tangent of 315, and that has a negative sine value here. So even though we do this fancy trick to get it to be a familiar first quadrant value, to respect the geometrical location of this terminal leg, which is in the fourth quadrant, we have to put a negative there. Because a sine is negative. If it were to land right here, though, the negatives would cancel. If it were to land right here, we'd again have to put a negative. Because the cosine would be negative, but the sine would be positive. Is that making sense? Good. So then what is this equal to? You said 1. I agree. Why? Because if...
2 over 2 over root 2.
Yeah. Put a negative on it. That's negative of root 2 over 2 over root 2 over 2. So this becomes a negative 1. Yes, the tangent of 315 is negative 1. Okay, let's do another one. Let's do let's do 150 or 510. What if this is 510 degrees of rotation? What is the secant of 510 degrees? We got to use reference angles. So the angle that this makes with the positive x-axis that is between 0 and 90 is that one. Clearly this, we could have talked about this angle. That's an angle it makes with the positive x-axis, but it doesn't lie between, theta does not lie between 90 degrees and 0 degrees. So we don't talk about this angle, we just talk about this angle. The smaller angle of the two. So what is the reference angle of 510? Because once we do that, that'll allow us to evaluate the secant of 510.
degrees, isn't it?
How are you coming up with that?
Man, I really don't want to explain it, but you know what? I will. Because you rotated around the x-axis once, that's 360 degrees, so 510 minus 360 is 150, and with the x-axis being 180 degrees flat, 180 minus 150 is 30 degrees,
Aha!
and it's inside 0 and 10 degrees.
So 510 is the same thing as 150. It lands in the same spot. Then you said, okay, since now that's really technically 150, this whole thing is 180 degrees. That means this piece must be this piece, 150 minus 180. So then I get this 150 minus a 180. Oh, wait, what? You don't want to have a negative value. Okay. So really you can say 180 minus 150. It's really their difference. You don't want a negative angle. I would have produced a negative angle. It's the same numerical value. 5, 6, 7, 8, so 30. The way I had it before, we got a negative 30, and we don't want that. That's not what our reference angles are. So you just switch the order to make it appropriate. Make sense? Okay. So the secant of 150 is just, or the secant of 510, dyslexia again. The secant of 510 is the same thing as the secant of 30 degrees. Are you sure? No, I'm not. Question mark, is it equal to just the secant of 30 degrees? Most certainly not, right? What do I have to put in front of the secant? And why? Maybe it would help to realize that secant of theta is equal to 1 over cosine of theta. So secant of 510 degrees is the same thing as 1 over cosine of 510 degrees. Because we're in the second quadrant here, secant of 510 is not necessarily purely equal to secant of 30. Cosine is what in the second quadrant? It's negative, right? So we have to put a negative here. So then this reduces to what is 1 over the cosine of 30 degrees with a negative on it. What is the cosine of 30?
It's 3.
Root 3 over 2?
Yeah.
Yeah. Cosine of 30 is root 3 over 2. So that equals negative 1 over root 3 over 2. And then when we multiply by reciprocals, I get negative 2 over root 3. And then when we rationalize, I get negative 2 root 3 all over 3. This is what the secant of 510 degrees is. So I would be expecting you guys to be able to do this stuff on your exam. It's not that bad, guys. First thing, when you get presented with like secant of 510, convert that to your sine and cosine. No matter what trig function you get, cotangent, whatever, convert that to sine and cosine. So cotangent would be cosine of theta over sine of theta. After that, look at the angle. Determine the reference angle. Evaluate the trigonometric function at the reference angle, which shows your familiar values. Then put the appropriate sign on it if necessary. Since cosine is negative in the second quadrant, You have to put that negative on it for it to truly hold. Or else you would have gotten that this equals positive 2 square root of 3 over 3. And that would be incorrect. Class is dismissed. Is this weekend a Labor Day weekend? So do we have school on Monday? We do? We still have school on Monday? I thought Labor Day was on Monday. And we still have school? Are you sure? So we don't?
Oh, no, you're the one that should know, you're part of this stuff.
That's why I'm asking you guys. We still have class?